Okay, so here we have a skier going down a slope on his brand new snowboard. He's going, and then we want to find that distance that he lands from the ramp. And we are going to use kinetic and potential energy to solve this problem. So the first thing that you should do is write down the full equation. I know it's really long and boring, but it helps set the problem up really nice. So you write the whole equation out, and you're like, okay, you start at the beginning. At the beginning, is he moving? And then that's where you answer in your head, yes or no. If he is moving, you keep it. If he's not moving, you get rid of it. In this case, he's not moving at the beginning.
Nope.
Does he have potential at the beginning?
Yes.
Cool, we'll keep that. Does he have spring energy at the beginning?
No.
No. Get rid of that. Is he moving at the end? What are we saying the end? Is the end here or here?
Taking off the ramp.
Taking off the ramp.
So yes, he is moving.
Curious. I wonder. Never mind. Yes. Potential?
Yes.
Okay. Can spring?
No spring.
Awesome. So this becomes our new energy equation.
That seems good.
mgh plus is equal to 1/2 mv squared plus mgh. Look at that, you guys. So much simpler. It is very nice. What's his mass? Hey, what happens to the masses?
We cancel.
Cancel out.
The masses cancel out. So nice when that happens. Okay then. Now this is not the same G as the other G. We'll make those different G's to differentiate them. Big G and little g. Big H and little h. I'm so sorry.
So we want velocity since we already know gravity and height.
Okay.
So just minus the g in lowercase h onto one side.
G H minus G H.
All square root.
So that's that velocity.
You did forget to times it by 2.
Oh my goodness, thank you so much. 2. Cool. Awesome. Now what do we do with things over there?
So now we have velocity, so here we could solve for kinematic.
Yeah, we do our kinematic equations. Remember those things that we thought that we were done with? Nope.
So we want to solve for the final distance of x.
Yeah.
So you have x final.
Do we have this angle?
It says 30 degrees.
Yeah, because underneath the belly of the ramp is 60,
Mm-hmm.
and the radius kind of makes a 90-degree angle.
Okay.
So from there you can kind of just
True.
make it
Yeah.
30 degrees.
Now, I don't... what do I not want?
So we're going to need the whole x final equals x initial plus v initial t.
Yeah. Let's see. Or, we want the time, right?
We'll need the time, yeah.
So we have v final is equal to v initial plus a times your time. We're going to do v final in the y, v initial in the y. And then our other equation that we're going to use is our constant velocity equation. That's your zero acceleration. Your v is equal to x over t. This is your velocity in the x. Velocity final in the x, I should say.
Vx final.
Yeah, vx. Just vx. Vy. Where do we get this v?
Did we just get them there?
Yes, we did. Now how do we get the y component of it?
How did we?
How do we? How do we?
Oh, we
Take
just
the
do,
Sine.
yeah, sine theta.
Cool. So v of y is equal to the sine of theta times all that nastiness. All that garbage. If you label it, you can use it. It's like I say all of this is stuff because I don't have to write it all the time. You can do that on a test if you want to. No problems.
Oh yeah?
Yeah.
Yeah, we can do that test.
No, really. I think I did this on a calculus test. It was pretty funny. Like I labeled all of the variables just like symbols in pictures.
Mm-hmm.
I did all the math that way. And then my teacher's like, "You're so dumb. Why did you do that?"
Because you had to work it.
Yeah.
It's so funny.
That's very fun.
Sine of theta times square root of stuff. So if you don't want to have to keep writing something, like if you have a giant equation that just keeps repeating the same giant component, just label it as something. Save yourself the time and the lead. Cool. Then you find your t. What's a? Do we have a?
Well, if it's y, then it's just going to be 9.8.
Perfect.
Really
T?
quick.
Yeah.
So this is our y final and this is our y initial.
Uh-huh.
So we know our y final. So what's our y initial?
Our y initial is that. Our y final is right here, right? Where it goes at the top, the apex of the slope. 0.
So this is our y
Initial. Yeah.
and this is our y
Final. Yeah. So I had them backwards.
Okay.
That is that one, and this is not. This is y
Final.
final. Okay. So your t is equal
So
to
that's initial. That's final.
sine of theta times the square root of stuff. All over G. Beautiful. Okay. Now we plug it into our that thing.
That's weird though.
Huh.
Because we had to use the quadratic to solve for t.
But they went.
Oh, wait.
the Y final.
That's only
equals
to
Y
there.
initial.
And that t doesn't work from there to there. So what are we gonna do?
Doesn't work.
Oh, no, that doesn't. I lied. The t, that gets us from here to here, but then if we times that t by 2, that'll only get us to right there, that point.
Mm-hmm.
So we need to do the thing.
Quadratic?
Is that quadratic? Can you do that? How do you do that? Yeah, let's try that. X is equal to x initial plus v naught times time plus 1/2 at squared. Okay,
But
we don't have time?
no, I was gonna say
Okay.
AX is gonna be 0.
Find time. A. Well, this is going to be y. We're going to use y's.
Why the Y's?
Why not?
Yeah, we
Why
had to
not?
solve for t.
Yeah, so then here we solve for t, because this y final, is that point, and y initial is that point. So label whichever one you want to be 0. You can have that one be 0, so that makes that 0 and that a positive 3, or you can have that 0 and that be a negative 3.
I'm sorry, can you repeat that one more time? Alright, so if this is going to be our reference points at 0,
Mm-hmm.
then this is,
3.
so this y initial is going to be 0,
That's y, yeah. Y initial's right here.
y initial is going to be 3, and y final will be
Yeah, that makes sense.
0.
That's-
0.
That makes a lot of sense.
Awesome, guys!
Okay.
So we solved for t.
Wait,
Yes.
we've already solved for t?
Mm-mm.
That was 0.
sadly.
That's some voodoo physics.
Wait, here we go. So we just plug in velocity. Okay, I know what I did. So we plug in velocity initial, which is GH minus GH. So GH2?
Sine of theta. Where? That one?
Yes.
Yes, it is.
Because, okay, can I ask a question?
Yes, you may.
So this is 3, and this is 25.
Okay.
Which one's 25?
The big H is 25. Okay. Yeah.
Gravity.
So now we can solve for the quadratic, which I have a calculator. and
G.
it's quadratic. Ha.
Ho, ho, ho. And then with that t, you plug it into here.
X over t.
X over t to find your x.
And what is our x initial?
X initial, that, which one? Oh, that x, that's the distance.
Then what is our...
Yeah, that's
Oh,
what we want to
vt,
find.
vx. This vx is the velocity in the x direction, that thing right there. Because your velocity in the x is going to be a constant velocity, meaning that
So it would be Vx times t.